Now today we're going to get into talking about statistical process control and how we can relate that to jet engine failures. Now, jet engine failures do happen, but they're usually non-fatal, so hopefully your flight doesn't end up looking like this. Now, you may ask, why does this happen? It could be mechanical problems, fuel leaks, and the list can go on and on. But what we want to do is use statistical process control to control this so this doesn't happen to you.
So you're probably going to be at the airport for some time because of a delay. And possibly statistical process control could have prevented that. So let's see what statistical process control can do. What it does is, using statistical methods, we can control and monitor the process, so it's basically quality control. There's two phases: establishment and production of the process. In phase one, what we try to do is locate and eliminate any special cases of variation so we can make the process more stable. In phase two, we're predicting future outcomes, and upon analyzing that data, we'll see if it best fits our case. So when companies use statistical process control, they can control the efficiency, quality, and cost reduction. Obviously, there are some variables that we can't control, like material costs and competition and much more. But with the ones that we can have control, we can improve the overall process. So when we use SPC, we're going to need data. Over here, you'll see a hypothetical data set showing the number of defects and variants. Now, with what we have is attribute data because we calculated the number of turbines that failed. From that, we can expect an average number of turbines that will fail. The other type of data is variable data, which is on a continuous scale. So examples of that are weight and height. So now with the data that we have, we can put it into an X bar R chart to show the variation of the mean and variation of the subgroup. I just made a simple line graph here to show you the amount of defects over time. Now with this, we want to set our upper and lower limits. In this case, 16 is the upper limit and 10 is the lowest. Anything that doesn't fit within these limits will have to be analyzed and corrected. In other terms, we have to find the cause and then make a correction to it so it will fall into the limits. Upon making those corrections, though, we might have to look into also readjusting our limits that might also have to correlate with the data set. So going back to turbine failures, if we use SPC, we can save your time so this isn't you again. And instead, you'll be flying away to your vacation getaway. Now, for a company, it means that we're going to be saving time, money, and have less effective units, which means less repairs. Because over the process of assembling the turbine, it does take over a year, we'll be identifying any issues and correcting them. So overall, we'll have a more efficient and effective product. Now, this was a very simple example of SPC, and I would definitely encourage you guys to do some more research on it, because 3 minutes isn't enough to explain the whole topic. But overall, thanks for watching, guys.